Hi, thanks for the invitation to speak at the 7th Nitrogen Conference. My name is Axel Garcia y Garcia. I am a sustainable cropping systems specialist at the University of Minnesota in the Department of Agronomy and Plant Genetics. My workplace is the Southwest Research and Outreach Center, which is located near Lamberton. I will be talking about the role of cover crops on mitigating nitrogen losses to the environment. To do so, I will use field research results from a 4-year study. Quickly, the first 3 or 4 slides will be about the issue we will be discussing today. That's it, nitrogen leaching, and then I will jump into my research results, and finally we will discuss some final remarks. Well, we all know that nitrogen nitrate is in the leachate is the main responsible for the environmental impact of fertilizer, nitrogen, and water quality. And to quantify that nitrogen that is lost is not that simple. It's quite complex, but we can do it. First, we need to know the amount of water that is drained below the active root zone of the crops. Uh, and then also we need the average nitrate concentration in the soil solution. For the drainage, we can do it using field scale facilities such as this one you can see here, and also we could use lysimeters, which are these ones. The lysimeter is basically an apparatus that we can use to grow a crop of interest, as you can see here. And then under this enclosed environment, we will monitor water fluxes, and we can have at the end the amount of water that is drained, and this can be used to determine the nitrogen nitrate in that drainage water. And finally, we can use a modeling approach. In my research group, we use both field scale facilities and modeling. The University of Minnesota has two field scale facilities. One is located at the Southwest Rock in Lamberton, and the other one in Waseca. The one in Lamberton is managed by my colleague Jeff Strack, and the one in Waseca by my colleague Jeff Vetch. So we know that cover crops can be grown in corn and soybean rotations for conditions in Minnesota. But we also know that the performance of those crops is actually, besides being affected by the same factors that affect any other crop, such as weather, soil type, and management, we have a main issue here, which is our very short growing season. Still, because we know that we can do it, we would like to know if cover crops could help reducing nitrogen loss, reducing nitrogen fertilizer amounts in the cropping systems, and whether or not the use of cover crops could help us maintaining or increasing the yield of the cash crops. That will be really nice, not only to know it, but also to have it. But as I was saying previously, the main challenge we have is the very short growing season. What you can see in this graph is a simulation study. What we did here was we used 30 years of weather data and a crop simulation model, and we modeled the growth of cereal rye starting on August the 1st in 5-day intervals for planting dates all the way to October 15th. October 15th will be here. Just I didn't add it because basically we did not have growth when we planted in October 15th based in the modeling. Anyways, there are some interesting things in this modeling exercise, if you wish. The first one is that there is a lot of variability on biomass within uh, a planting date. You can see, for example, for August the 1st here, that the biomass that is produced by the cover crop, in this case cereal rye, can be as little as less than 1,000 pounds per acre and as much as more than 3,500 pounds per acre. And then similar for all the other planting dates that we have in this simulated study. Another interesting thing we can see here is that the earlier we plant, the more biomass we can have from that cover crop. And then we can also see that when it's time, when we usually actually seed cover crops following corn and soybeans, this happens from the second half of September to the beginning of October. That means somewhere from here to here. Okay, so when we do that, what we are doing is planting too late, and as a consequence what we get is a very little biomass. A maximum of around 700 pounds per acre is possible, and the minimum can be as little as very close to zero, so marginal. And I am telling you all these things because the amount of nitrogen that is used by the cover crop and the amount of nitrogen that cover crop could eventually help us reduce in terms of losses to the environment is directly related to the amount of biomass that is produced. Anyway, so I wanted to talk to you today about 4 years research that we conducted within the Research and Outreach Centers of the University of Minnesota. And this research was divided in two studies. The study one was conducted within the University of Minnesota Long-Term Agricultural Research Network and consisted of corn soybean rotation with cereal rye based cover crop strategies. The experimental setup was a randomized complete block design with 3 replications in Grand Rapids and 4 replications in Lamberton and Waseca. The study 2 was conducted in drainage field scale drainage plots at Waseca. So we also had a corn soybean rotation with cereal rye on fields with the tile drainage plots. The experimental setup was a 2x3 factorial with 4 replications. In the study 1, which was conducted at 3 locations, we also had, as a consequence, different soil types. In the north central rock in Grand Rapids, we had a well-drained Nash Walk loam soil. In the southwest rock in Lamberton, we have a well-drained Normania clay loam, and in the southern rock in Waseca, we had a poorly drained Nicolette clay loam. The cereal rye based cover crop strategies were cereal rye alone, cereal rye mixed with crimson clover, then a mix of cereal rye, crimson clover, and forage radish, and a no cover crop control. The nitrogen nitrate in the soil solution was monitored with ceramic cups installed at a depth of 3.3 feet. Drainage water was not monitored in this specific study. In the study 2, which was on a field scale drainage plot, corn soybean rotations with cereal rye on experimental fields uh, were set uh, in tile drain plots installed in 1996. The experimental setup, which was a 2 by 3 factorial combination of two management factors, consisted of cereal rye and no cover as the cover crop, and the N rates were 0, 120 and 150 pounds per acre. The nitrate nitrogen from drainage water was obtained directly from the drainage that was measured in each one of those plots. In all studies, the cover crops were interseeded. Actually, we hand broadcasted and then rake incorporated into corn at dent to maturity, which is R5, R6, and soybean from the beginning of dropping the leaves when it starts to get yellowish to maturity, which are R7 and R8. The seeding rates we used were 60 pounds per acre for cereal rye as a monocrop cover crop, and then half of that rate, that means 30 pounds per acre for cereal rye when mixed with crimson clover and forage radish. Crimson clover, when was in a two-way mix, was used at 20 pounds per acre, and 15 pounds per acre when it was in a three-way mix. In the case of forage radish, we use 9 pounds per acre. In the spring, cereal rye was killed with glyphosate between 1 to 7 days before planting corn and soybeans. Okay, jumping into the results. For the study one, which is the one that was conducted at 3 locations within the Long-Term Agricultural Research Network, you can see in this table here basically that the yield of corn was affected by the location and by the cover crops, no, I'm sorry, by the location by year interaction only. Okay, the concentration of nitrogen in the leachate, on the other hand, was affected by the location, by year, by treatment, and by the location by year interaction. So that tells us a lot, because in the case of corn, we already knew that location and the interaction that of location by year might be a factor that will affect it. But in the case of nitrate, for example, location is about weather, mostly rainfall, and soil type. Year the same, and then we have the different cover crop treatments here, and then the location by year treatment. Notice that there were no effects in both variables when it comes to location by treatment and treatment by year and the three-way interaction. No effect at all. As a consequence of that, obviously, what you can see here is that grain yield of corn was not affected by the use of cover crops. Basically, in all 3 locations, from Grand Rapids, Lumberton, and Waseca, and from each of the 2 years that were analyzed here, the yield of corn was not affected by the use of cereal rye cover crop and its combination with other cover crops. So the question is whether or not that cereal rye provided us some ecological services. So what you have here in this graph to your right is the nitrogen in the leachate at the 3 different locations during the fall, during the spring and during the summer. Uh, there is a couple of things I would like to show you here. First is that we only had, significant differences between treatments in very few instances. One is here, another one is here, another here, and another here. So what you can see here is basically is telling us, in this case, for example, in this case here, is telling us that there is a significant difference between the different treatments here, and those treatments are the red one is cereal rye monocrop, this one here. Uh, then we have the green bar is this cereal rye with crimson clover. The blue bar is the three-way mix of cereal rye, crimson clover, and forage radish. And this bar here, the pink one, is the no cover crop or control treatment. So the bigger the bar, it means that there is more nitrogen concentration in the soil solution, and therefore we can conclude that the potential for nitrogen losses are higher. In other words, this is telling us that the control, which is the one that had no cover crop, was showing more potential for nitrogen losses. In the other instances, even if the differences were not significant, you can see that the control tend to be higher than the others. Okay, and this is important because it's basically telling us that yes, cover crops really help us reduce nitrogen losses in this system. So that's why you can see that I wrote here for us that cover crops reduce the concentration of nitrate nitrogen in the leachate. In the study 2, which was conducted in Wasika, which is about the effects of cereal rye cover crop and nitrogen rates on corn yield, nitrogen leaching, and drainage. You can see first that yield of corn here in this table is the only one that was affected by nitrogen rates. Okay, yield of corn was not affected by the cereal rye cover crop, which is this one, and nitrate nitrogen was not affected by either one. Cereal rye and nitrogen rate had no effect on nitrate, and drainage water consequently was not affected either. And this is basically because, as you can see in this graph here, the amount of biomass that was produced by the cover crop was marginal. We are talking about, this is in kilograms per hectare, we are talking about 200 to 230 kilograms per hectare of biomass. So this is basically nothing, so no effect or whatsoever. The results from the study 2 actually were something that we were trying to figure out if we could find some other differences. So what we did was, first we compare for the averages for the whole season in a yearly basis, and you can see that when we have all seasons together, the only one that had significant difference was the no cover by cover crop treatment here, and the no nitrogen with the maximum nitrogen rate here. And then what we did was we split each one of these years, as we did with the previous study, into spring, summer, and fall periods. Okay, and you can see again that we had significant differences only in 2017 during the fall time, for each one of these three combinations here, which are no cover versus cover crop here, no nitrogen versus 120 pounds per acre here, and no nitrogen versus 150 pounds per acre here. Well, we wanted to go further and determine how that difference will look like, and actually you can see here that in fact there are large differences with the, for example, the non-nitrogen and the nitrogen, the highest nitrogen rate, or the non-nitrogen with the 120 as well here. So you have the nitrogen here in the 120 here, and then for the no cover crop in the cereal rye cover crop here. So the way to see at this is the difference that exists between these two curves here. So the larger the difference, the more differences, the more significance in the difference is. So the other thing we did was we used the observed data to model what was going on at field, and what we found was is really interesting. The first two graphs to your left, which are these two here, show you the observed and simulated results from the cereal rye and the no cover separately. So you can see for the cereal rye that the observed were around 5 kilograms per hectare of nitrogen that you know were lost. In the simulated, we got a little bit more, around between 6 to 8, but the simulated results show us that there is a lot of variation. Okay, and then in the no cover, well, another thing in the cereal rye is that basically we can see that there is a tendency on having more losses with more nitrogen. This amount of nitrogen here is in kilograms per hectare. So in the no cover, similar, just with the difference that the simulated values here were much more related in terms of the magnitude with the observed data. Then we use that modeling and we apply it to the different locations we had in our study. That means in Grand Rapids, Lamberton, and Waseca, with cereal rye and no cover. So we found that in Grand Rapids, for example, we have more or less a 50% reduction in nitrogen loss with the use of cereal rye. In Lamberton, that reduction was about 13.5%, and coincidentally, a study that was conducted by Struck et al. In 2004 reports that using cereal rye for conditions in Lamberton, we might have a reduction to up to 13% on nitrogen losses in the system. So this value is very close to what we found ourselves here. So we were happy with this number to see that this matches. And in Waseca, the average simulated loss reduction was about 8%, which was the lowest. And this is because our soil in Waseca, as we showed previously, is a really very poor drained soil. Well, our final remarks are that in fact, cover crops reduce nitrate leaching in the corn-soybean rotation, but results are highly affected by weather, mainly rainfall. Location matters. Locations with heavy soils have less nitrate concentration in the leachate than locations with lighter soils. Late interseeded cover crops do not affect yield of corn and soybeans, which is actually good. With that, I would like to thank the support of the Minnesota Department of Agriculture through their Clear Water Funds and the Minnesota corn growers. I would also like to thank, my technicians and my grad students and the field crew of the Southwest Research and Outreach Center in Lamberton for all their support. Uh, Thank you very much for your attention, and as possible, I would like to hear from you during our Q&A session. Thanks.